All right, so we just talked about the quotient ones with the unit circle. We're gonna hit the unit circle one more time and look at the triangle and everything inside of there. We're gonna look at that part, but then we're gonna go into the other part. So Pythagorean identities here. The first thing we're gonna do before we actually go into the Pythagorean identities, so let's talk about Pythagorean theorem again. So you've had this before, you've seen this multiple times. We've talked about this with vectors and how to solve vectors out and everything, find the magnitude of that vector. We did Pythagorean theorem there, so hopefully this is not brand new, or hopefully you didn't forget it, because I know it's not brand new because we talked about it. But hopefully you didn't forget it, and hopefully you guys remember that this is just a squared plus b squared equals c squared. So Pythagorean identities come from Pythagorean theorem using our unit circle. So that's going to come back into play here. So real quick again, we're going to draw this circle out. We're going to have the x and y planes and all the good stuff. We said again, this is our x. This is x here, x-axis. We said this is part is our y-axis right here. We said we had a right triangle because we were talking about right triangle trig stuff last year in Math 3. All right, so here we said the bottom part, x was our cosine theta, which is our angle. Again, theta is the same thing as saying x. It's our angle. Again, theta is the circle, and then a curly q at the end. Same thing as x. If I say same thing, same thing as x. So if x is an angle, theta is an angle, pretty much all at the same time. All right, so then sine is here. That equals 1. So if we're talking about Pythagorean theorem, the a squared plus b squared equals c squared. All right, so pretty much we can say this is our side A, this is our side B, and this will be our side C. So here, if we do that, this will be cosine squared theta plus sine squared theta equals 1 squared. 1 squared pretty much is just 1 because we know that already. So technically we have this. And you guys know what? This is actually one of our Pythagorean identities. Using Pythagorean theorem from our right triangle inside of our unit circle. So putting it all together. So again here, I interchanged the thetas and the x's because when it comes to your work, you might see thetas there, you might see x's there, you can see betas there, you can see gammas, you can see t's, you can see multiple things there. So don't get to the point and be like, Mr. Hall, I don't know what you're talking about. What happened? Where did this come from? All right, so our first trig identity for our Pythagorean theorem, Pythagorean identities, is what we just wrote here. So the same thing here is the same thing that's right here. They're the exact same thing. Now, for Pythagorean identities, there's actually 3 of them. So for the first one is this. This is number 1. Number 2, we're going to use this one to help us to find the other 3 for number 2 and number 3. So here, I'm going to clone this real quick. We're going to go to number 2. Oh, making all this noise. Sorry about that, guys. All right, so we're going to come here and we're going to go ahead and look at this part. So really the identities are really easy to find. So with this part, what we're going to start off with, get my data first. We're going to divide everything by cosine squared. And whatever you do to one side, you got to do to the other side. And so here, we're going to divide everything through by that. All right, so our quotient identities are going to help us here. Our reciprocal identities will help us here also. So cosine squared over cosine squared is just 1. If you look back at the quotient identities that we just did, we said sine over cosine is tangent. But here, because they're both squared, we'll say tangent squared. So again, this is from our quotient identity. All right, and then the last one deals with our reciprocal identity that we just talked about at the very beginning, like earlier in the class. So the reciprocal identity means you're flipping, well, you're doing 1 over cosine, and we said the reciprocal of that is secant. And because it's squared here, cosine squared, we do the reciprocal of that is cosecant squared. So our second rule or second identity is right here. So 1 plus tangent squared x equals secant squared x. Okay. This is all, we're kind of getting this, kind of, sort of. No, we're not all, we're getting this at all. All right. So again, once we're doing this to derive, to tell like where they're coming from, but once we actually get it, the part that you have to remember are the actual rules itself, the actual identities itself. All right, so we have the cosine squared plus sine squared equals 1. We have the 1 plus tangent squared x equals secant squared x. And then the last one here, for number 2, we divided by cosine squared. For number 3, we're going to divide by sine squared. And no, we're not going to divide by 1 because it's not going to do anything. If we divide everything by 1, it's going to come back to be the exact same thing. So no, we're not going to do that part. But the big part about this is if you got the first one, you can find the other two pretty easily, pretty quick. All right, so again, using our quotient identity here, quotient identity. All right, so we're using our quotient identity. We know cosine over sine is cotangent. And because it's square for both of them, we said cotangent squared. Sine over sine is 1. And then our reciprocal identity, we have 1 over sine, which is cosecant. All right, so with this, that's our third one. So that's our third and final one. So for our Pythagorean identities, we have those 3. So I'm going to rewrite them one more time down here at the bottom. Make sure you capitalize the P for Pythagoras. You have to give him respect because he's done a whole lot of work for our math, for what we have now for math. Some of you guys are like, where do we have to do this? Where did math come from? Pythagoras was one of those that helped out. I love Pythagorean theorem and all that good stuff. Pythagoras. And reminder here, guys, don't forget x is the same thing as saying theta. So if you put thetas here instead of x's, that's fine. I want to do cotangent. No, sorry, let's not do that yet. Let's do the other one. Cosecant. All right, so those are our 3 identities, guys. And so we have those. So now we're going to start using them. All right, here we go.